everyone. Let us now discuss today's LeetCode POTD problem, most profitable path in a tree. Without reading all the description of the question, let me explain you simply what does this question give us. We are given with a tree, a binary tree, and we are given with two persons, right? With A, that means Alice is starting his movement from node 0. Now we have another person B, Bob, which is starting from node 3. Like this is an arbitrary node. So we are given with two persons and Alice's target. Her target is to come to the leaf node. She starts from here and she need to come from here to the leaf node. But any leaf node, she can come to any leaf node. And what is the goal of Bob? Bob is starting from here and he need to go to the root node, to the node 0. Now let me say another thing which is given in the question, right? What are these values? Minus 2, 4, minus 4, 6 and 2. So imagine these nodes are like a gates. To open this gate, you need to give 2 rupees. That means your value will be decreased. The amount you have will be decreased by 2. And to open the gate 1, you get 4 rupees. So the value or the amount you have will be increased by 4. And if the gate is already opened by other person, you neither get amount, neither you get amount, neither you lose your amount. So let me go through the same example which is given in this question. Let me go through this example. So here Alice starts from node 0 and Bob is at node 3. So Alice is at node 0 and Bob is at node 3. Now here Alice is at node 0, so he need to open this gate and this value will become 0. Now the another important thing I forgot to say you is when they meet a node at the same time, the gate at the same time, then the value is distributed among themselves in equal proportion. That means if they have 4, then 2 is given to Alice and 2 is added to Bob. Now let me go through here. Minus 2 is given 0. So that means the gate is open and the value of Alice is changed from 0 to minus 2. Now let us go to Bob. Here Bob is also started his journey with 0. Now minus 4. That means here it would be minus 4 and this will become 0 as the gate is opened. Now where does Alice go? Alice have only one node which is adjacent to the root node 0, which is 1. Now the value at 1 is 4, but before that Bob is also moving simultaneously at here, right? Now they both met at the same point and now it is the node 1. The value at node 1 is 4. I'll add 2 to Alice, then the value will become 0. And I'll add 2 to the value of Bob, then it will become 2 minus 4 minus 2. And let us go to the next one. Here, as I said, this would become 0. This would become 0. Now, both Alice and Bob are at node 1. Now, let us see why does this Bob move to node 1 but not node 4? Let me explain you why did he do that. Because by moving to 4, he is going to the distance from 0. So he is going far away from 0. So he need to go or choose the path which takes him to node 0. So let me tell you in few seconds how this could be solved by using some algorithms. But before that, Alice is at node 1, Bob is also at node 1. Where does Alice go? Alice can go here, he can go here. But if he go here, then he would get a profit of only 2. And imagine he also gone there. Now, imagine he didn't go to node 2 but went to node 3. Now, as I said, simultaneously Bob will also move. Now, Alice is at node 3, Bob is at node 0. Bob will stop moving further, but Alice have to move. But before that, the value to open the gates, the value to open the gates at both are 0. So there will be no change to Alice and Bob. So Alice is at node 3 and Bob is at node 0. As I said, Bob's goal is to go to node 0 and he reached his goal. Now Alice have to go to the leaf node. Now, the only leaf node which is present adjacent to Alice is 4. And if he go to node 4, then he would get a profit of 6. So if I add this profit, it would become 6. Now, the main goal of the whole algorithm, sorry, the question is to return the maximum profit of Alice. So I'll write the observations which I observed. The first thing, Bob have to go to node 0. This is the first observation. And the second observation, Alice have to go to leaf node. But this also says that he need to get maximum amount. Now, there is a like something problem here, because here you have 3, before it was -4. Now Alice came here, but if you didn't change it to 0, you would add this -4 to the value of Alice. So we need to take care of that before. Now let us see what happens here. Now this is the second observation, and our goal of this question is to return the amount of Alice. This is the goal of our question. Now let us see how can we solve this question by taking time considerations. Now let me say that here you got Alice at node 0 and Bob is at node 3, right? So let me take this all now. Let me take this all. Alice is at node 0 and Bob is at node 3. Now imagine at 0 amount of time Bob is at node 3, and at 0 amount of time Alice is at node 0. Now Alice came here at time 1 and Bob came here also at time 1. This is the time or the node where they are at the equal node. So it is quite simple. But how can I know that Bob should take the value or Alice should take the value? So if you see, Bob is going from node 3 to node 1 and then he is going to node 0. Node 0. Now, Bob is going from node 1 to node 0 at the time of 2. So, allies have arrived to node 0 before Bob has been arrived. So, allies have, let us say allies arrived, sorry, Bob arrived at second hour, but allies arrived at 0th hour itself. So the door was opened before Bob has even reached. This is how I know whether the door is closed or open. Simply whether should I add this value or not. So my observation will be if the other person has already arrived, then no need to add the value. But how do we know that? So to knowing it, we need to do one thing. We need to go through any traversal. So let me say if I traverse this alive allies. So I'll go through these elements or these nodes and or add these all values. But this would be wrong because allies have stopped adding the values at here itself, and because these nodes have already visited. So instead of taking allies first, I'll take the DFS or any other algorithm for Bob. So I'll do one thing. I'll go through a DFS for Bob and it will be hitting 0 and I'll stop it. And I'll store when the node is visited, the time is marked. Now I'll store it in a vector of int. Now, how do we know that? For this question, I will go through the DFS of Bob and store the time at every node in a vector. So this is how I store the values. But the other observation is at 0 of ally's time, 2 is the time where Bob has arrived. So ally's arrival time is less than Bob arrival time. That means Alice has arrived before Bob has even arrived. So the value will change. But Alice's arrival time is greater than Bob arrival time. So there will be no change at all. If you see here, Alice will be arriving at this node at the time of 2. But Bob has started his journey at node 3 with a time of 0. So this gate is already opened. So if Ali's time is greater than Bob time, then there will be no change. Now there is another problem where Ali's time is equal to Bob time. So at this time, as I said, it will be splitted by 2. Now these are the conditions that I need to take care of. Now I have another thing. I have arrived this Bob to 0 and allies. What should allies do? Allies will store the amount at every node by doing a depth first search for every node. And this Bob, if he is not getting a root node, the 0 node, then it will backtrack and go through the node which is giving the root node which is 0. So you will understand it when you see the code, but before that, try it yourself and make note that DFS would be used first for Bob, and he will store in a vector of int the time and also the arrival time and also the node where it is arrived. The time at which the node is arrived will be stored in a vector int, and this, by using these three conditions, I will go through the searching for allies for a leaf node, searching for allies for a leaf node, and I will return the maximum profit that allies would make. So give it a try. This is an easy question if you know how do we solve this by using a searching algorithm. So if you like this video, share it to your friends, and the link of the code is in the description. So go and check it if you can't solve this problem, and thank you.